Okay, this is a recording for Friday, 12/14. If you are absent, we are going over the rest of this section. As I looked at things, there's a lot to go through, and that's a reason why I decided to still record it, because we have a lot of people back. But if you were gone, hopefully you got a piece of paper or something to write on, because there is a piece of this that's very new to you. So the fundamental theorem of algebra says that a polynomial function of degree n, where n is greater than 0, has at least one zero, real or imaginary. Now, that's different than anything we've said so far, real or imaginary, in the complex number system. And so that's very general. It's just saying it has at least one zero. There's a corollary that says a polynomial function of degree n has exactly n zeros, including repeated zeros, in the complex number system. So if we have x plus 2 in parentheses to the third, that means -2, -2, and -2 would be the three zeros. And if we multiplied that all out, it would start x to the third. And if we are looking for the zeros and it's x to the fifth, there's exactly 5 zeros, and we'll be able to find all 5 of them now, as long as we can go into the complex number system. So you know you've gotten a quadratic before. I feel like we maybe got one yesterday that was like x squared plus 1 in one of our last problems. And and we just stopped there and said those aren't real. But then today we would say, oh, well, x squared plus 1 is the factor, so x squared plus 1 equals 0, set it equal to 0, subtract 1, and we could get plus or minus I. Give me a little head nod if you're agreeing with that plus or minus I thing. And otherwise, we would have a quadratic, and we can put it in the quadratic formula and either get irrational or complex zeros. Do we all agree with that? So if we can get it down to a quadratic, we'll get those. And another thing to know is that our complex zeros come in conjugate pairs. Do you remember what conjugate pairs are? 5 plus 2i, 5 minus 2i. And think about that whole quadratic formula. X equals -b plus or minus the square root of blah, 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 all over 2a. And so that means we're taking this first thing and we're either adding that radical or we're subtracting that radical. And so if we end up with an imaginary thing, it's still going to give us a positive and then a negative as we go. And then if we extend that, and we can find this linear factorization. And so this is where we kind of up our level of difficulty. So until right now, these factors have all been like, x minus 2, x plus 5, maybe 2x minus 1, so we'd get a fraction and things like that. But now this c could be a complex number, and it could be a complex number in the form, 5 plus 2i. So we'd have x minus, and then an extra parenthesis, 5 minus 2i, and then x minus, in parentheses, 5 plus 2i. So if the polynomial function f of x has a degree greater than 0, then f has exactly n linear factors where a sub n is some non-zero real number. So maybe it was a common factor through all of that. And c1, c2 through cn are complex zeros, including repeated zeros. Now, it says complex zeros, but remember, a complex number a plus bi, well, if b is 0, it's just a number, right? And so, it could be just a 5. And also, if a is 0, then it's considered a pure imaginary number, where it would be maybe 5i or something like that. And so this is saying everything can be factored completely into these kind of notice it's calling them linear factors, and it's not saying the word binomial, because the factor could actually be x minus 5 plus 2i. And that's the factor. X minus c is actually this complex number. And then we'd have x minus 5 minus 2i. And we're going to have to multiply those out and figure out kind of what that gives us. So the next thing there is just according to the conjugate root theorem, and that is just saying that we get these conjugate roots in pairs, a plus bi and a minus bi. So if you kind of think about this, if I know all of the factors, I can write them like this, and I can multiply them out using the distributive property or sometimes the FOIL thing, and I can get a big polynomial. And then a sub n, you can always let it equal 1. Right? If you're making a rule, or if you ever wanted to, you could put a 2 in there. I have never had a student who's taken a number and distributed it through and made a different rule that would be correct as you go, but you surely could. Another thing I'm going to tell you that's going to be a trick or something to be aware of. And if they give you one of these, they're going to expect you, and I'm going to expect you, to know that there's a second one, okay? So I might just say, I don't know, what did I use up there? I might just say 5 minus 2i is a 0. Then you have to know, oh, if 5 minus 2i is a 0, so is 5 plus 2i, because you won't be told that. Okay, and then any other zeros, you can think of their multiplicity or having them not be repeated at all. So this first kind of problem, the challenge is just carefully multiplying and making sure you don't forget about any of these zeros or whatever as we go. And keep in mind, c sub 1 is the 0, so x minus c sub 1 is the factor. And please use extra parentheses if it's a complex number as we go. So here's the next one. This says write a polynomial function of least degree, because it could have a higher degree because they could be like, squared, the different factors or whatever, but of least degree in standard form that has -1, 2, and 2 minus I as zeros. So when I write this one, I'm going to say that the zeros given are -1, 2, and 2 minus I. And then I'm going to remind myself that, and I'm going to use a different color when I do this. That's a 0, that's a 0. If 2 minus I is a 0, I have to say to myself, oh, then 2 plus I is. And so I know 2 plus I is also a 0. And here's another clue to that. If you try to write these three things as factors and multiply them out, you're going to have a mess with a bunch of i's in it. And if you use these two things as factors and multiply that out, all the i's should drop out, right? Because you're going to get an I squared, and the I squared is equal to -1, and all the other I things should either have a plus this many I and a minus that many I. So that's another clue to you that you're going to do this correctly. So the first thing we do is we take these, now there's really 1, 2, 3, 4. So I know right now that my answer is going to be x to the 4th. Do you agree? I'm going to know that at the end I'm going to have x to the 4th. I'm going to write these as factors. And since we have people not here, I'm just going to write them out kind of as long as I can. The book authors often use a bracket and then parentheses. I'm going to use nested parentheses, more than one parenthesis. So if that's a 0, I'm going to say x minus -1 is a factor, x minus 2 is a factor, x minus this, parentheses 2 minus I, is a factor, and the one I came up with, x minus, in parentheses, 2 plus I. So, I have a lot of time to kind of fix that other one, so I'm not in a super hurry to kind of clarify that. That's x plus 1, right? This is x minus 2. My way of doing this would be I would distribute those two, just because I'm familiar with them and they're easy. And I would definitely never multiply like that and that. It's just going to be a mess. I would multiply these two together for sure, because there the I should drop out. And I don't care how fast I do this one. So right now I'm just going to write x plus 1, x minus 2. And I'm going to rewrite this one dropping those parentheses, because I know that I have to distribute these negative signs. So that's x minus 2 plus I, x minus 2 minus I. And kind of look at what happened to those signs. Just like when this was a positive 2, it's now minus 2, and that happened there, and I get a plus I and a minus I. And now we'll distribute those out. So I'm going to have you distribute it for me, and I want you to talk just a smidge slow, because I'm going to just repeat every term as you say them. Does that make sense? So that I kind of know what you said. So go ahead and do that for us, Peyton. Just these first two. What do you get? Yep. X squared. So these two terms gives me what? Minus 2x. I'll write it because I have a lot of space here. And what's that going to be? Plus x. Oh, plus, I was going to write 1x, but I'll just write plus x. And then multiplied last terms is what? Minus 2. Keep in mind that has to stay in a parenthesis because these are all multiplied together. And then this other one, I'm going to actually color code it. And I'm going to have a person just distribute one variable at a time. So Delaney, I'm going to ask you, this is what you're going to do. You're going to take that x times each of those. Does that make sense? So just tell me what those are. X squared minus 2x. I'm going to put the I first, minus ix. So that's that piece of it. And then, Colin, I'm going to have you just distribute and it's negative 2 you're distributing, times each one of those. Minus 2x plus 4 plus 2I is that next one. And then distribute just that I for us, Cole. And then I'm going to close that parenthesis. So now look at that carefully and just give me a head nod. Are my i's all going to cancel out or become like -1? So I'm just going to go through. There's a minus ix and there's a plus ix. And plus 2I and minus 2I. And I'm telling you right now, that should always work that way. So if it doesn't, look back and see if you multiplied right. Look back and make sure that you did this distributing of the negatives. Make sure you were using conjugates as you looked at that. And then I'm also just going to change that minus I squared. I squared is -1, and so it's going to be minus -1, so I'm going to write plus 1, and then hopefully I won't forget about it. So now I'm just going to combine like terms, and like I said, I'm kind of leisurely doing these two because I just knew the other one took a lot of steps. So x squared minus x minus 2 is on that one, and now's always a good time for me to make sure that I end up with what I thought. This is going to be x squared. And then I have minus 2x and minus 2x, so that's minus 4x. And then I have plus 4 and plus 1, so plus 5. So now I actually have to do that same kind of problem where I'm going to take this times all of those and then this times all of those. And so that will give me my kind of end result. And now you know why I never have students who will just like at the end multiply everything by 2. Because my gosh, the problem's long enough. You know, why would I do more as I go? So let's go with the x squared here. Kaylee, will you just take that x squared times each of those terms for us? Okay, so we've got all of those, and then distribute that negative x for me. Okay, go ahead and do that. Mm-hmm. And then Matthew, the last one, negative 2, distribute that. Okay, and then finally, it's a matter of just combining our like terms as we look at that. I'll maybe do that, and sometimes I do a little just underlining to make sure I don't miss out on anything. So I've got the x to the 4th, that's the first term. For x to the 3rds, I've got that one and that one, and so minus 5x to the 3rd. Then x squareds, I've got a 5x squared, a 4x squared, and a minus 2, so 9 minus 2 is 7, plus 7x squared, and then my x's are just this one and this one. Negative 5x plus 8x is yes. And then minus 10 is just minus 10. So this could be our function f of x. And of course, I could multiply it by 3. It asked me for the lowest power, so I wouldn't have squared or cubed any of those other ones because it's plenty of work to do. So you will have to do problems like this as you move through. And I just want to look at this piece that I was at a minute ago. So yeah, I can just see everything. So do you agree that, and this is just to kind of think further ahead, that piece right there factors into that, correct? So that quadratic is factorable. But this one, the roots are, 2 minus I and 2 plus I, because I can't see that previous one. And so this one, if I put it, I can't factor it, which should make sense to you anyway. If this is a plus 5, I can't have 2 positives or 2 negatives. At first glance, it looks like it might factor, but I can't do that. It won't factor. If I put it in the quadratic formula, I'm going to get complex zeros. So sometimes I'll factor things over the real numbers. And this is a different problem. It's like starting with this problem. If you had to factor this, you would do P over Q. Do you know what I mean when I say P over Q? You would do P over Q and start synthetic division, and you would probably find that -1 and +2 worked, right? And then you would have this quadratic left. And so then you would find that this does not factor. And even if it didn't factor, we'd put it in the quadratic formula because it could be irrational, not complex. And so the reason I'm kind of looking at this is because there's another thing that we can do, and that's factor over the reals. If we started with this and we wanted to factor it just over the real numbers, we would say it was this times that, because that can't be factored and the answers are complex, not real. And so I'm kind of going backwards and looking at maybe things that we've done before as we've looked at that. So this is called factoring a polynomial over the reals. And so think about what that means. Every polynomial function of degree n greater than 0 with real coefficients can be written as a product of linear factors. Okay, I can't remember what they were, like x minus 1, x plus 2, or it was the other way maybe, whatever it was. Those are linear factors, right? And then a product of linear factors and irreducible quadratic factors. And so that was the x squared with the 4 and the 5, right? That is irreducible. And probably a long time ago you've learned about irreducible, you know, when you were learning to factor, and it wouldn't factor, and you couldn't find a solution for it. So now we want to factor a polynomial over the set of real numbers, and we know our strategy. We're gonna start with a higher power. It's gonna be x to the 5th. So how many possible zeros are there? 5, right? But that's including conjugate pairs. So there's either 5 real ones, 3 real ones, or 1 real one. Do you agree with that? So that's kind of the extra thing that we're getting right now. And so here's our problem, 7a. K of x is equal to x to the 5th plus x to the 4th minus 13x to the 3rd minus 23x squared minus 14x minus 24. And it says write k of x as a product of linear and irreducible quadratic factors. So that means if that last one won't factor under the real numbers, we just leave it as x squared, whatever, you know, and probably it's just going to be that one. So p over q, a little ugly. Do you agree? It's got a lot of stuff there because of this 24. So, but no fractions, correct? Because this x to the 4th is, or x to the 5th is 1. So p over q. Who thinks they can tell me all those factors from 1 to 24? Well, I shouldn't have asked who could do that. Are you volunteering? Go ahead. Okay, and just to make sure we didn't miss any, 1 and 24, 2 and 12, 3 and 8, 4 and 6, you know, so we've got them all. I quit putting commas, but since I was looking at, to kind of make sure I was hearing them all, I quit putting the commas. And we've talked about several things. Things out to the ends are, less likely to be, you know, zeros. And I'm going to use this problem as kind of a review of the things that we've learned. So we've learned the P over Q. Now I'm going to use Descartes' rule of signs to decide how many positive or negative real roots there could be. So Descartes' rule of signs. And I'm just going to write the word Descartes. Number of possible positive real roots. Just to kind of get an idea in my head. So if it's positive, there's one sign change, correct? One sign change. So there is one positive. So I might search for that one right away, right? Because, you know, I'm hoping it's an integer number, but I feel like it might be. And then for k of negative x is negative x in parentheses to the 5th plus negative x parentheses to the 4th minus 13 negative x to the 3rd minus 23 negative x squared minus 14 times negative x minus 24. And so k of negative x, negative to the 5th is negative. Negative to the 4th is positive, so plus x to the 4th. Negative to the 3rd is negative, but then negative again is positive. Negative squared is negative, or excuse me, is positive, and this stays negative. 23x squared. Negative negative is plus, and minus 24. So then the number of possible negative real solutions, and now I just have to count. So it's negative to positive. There's 1 sign change, 2, 3, 4, right? So there could be 4, 2, or no negative real solutions. So I'll slide. Ooh, oh, I got a little spinning wheel. 4 or 2 or 1. Oh, 0, sorry. So I was back to thinking about this one. So this is to the 5th. So I could have 1 of these and 4 of these. That would be 5, right? Or I could have 1, 2, and then like 2 complex ones. And I'm just going down to real, and then I could have 1, none, and then 4 complex ones, correct? I'm less likely that I would have it that way, right? If I have to actually do this problem, because I don't know the means to doing that. And then I'm just going to keep in mind the factoring problems as I kind of look at things. So I'm searching for this positive answer. I'm going to see if I can find it. And so 5, 4, 3, 2, 1, 0. And I'm going to write this, and then I'll slide it up because I have to be able to see this. My coefficients are 1, 1, negative 13, negative 23, negative 14, and negative 24. And I'm going to do that short row, okay? I might need some help. Okay. Oh, sorry. In case I forget, B is a continuation of this problem, okay? So I don't want to start it all over, which I could actually do. Okay, ready now? Okay, so theoretically I can see P over Q, but it's like 1, 2, 3, 4, 6, right? So hopefully I'll remember not to try anything that doesn't work. So let's just kind of go through this. I'll bring down that 1. I didn't leave myself a lot of room. 1 plus 1 is 2. 2 minus 13 is minus 11. Negative 11 minus 23 is negative 34. I was going to say, do I have to keep going? Because think about this. It's going to be negative 34 minus 14. That's a negative. Negative whatever minus this. So it's going to keep being negative. Do you agree? So, you know, at some point, if you're confident in that, then you can quit, but be careful. You know, you don't want to quit too soon if it's something that's going to, in the end, work out. So then I'll put my 2. I'm a little unhappy with myself for having those so close together. So now this is 2 and 1 is 3. 6 minus 13 is negative 7. So negative 14 minus 23 is a negative number, right? That's more negative. And so negative 14, negative 37. And so do you agree that this one also is just going to get more and more negative? So I'm going to have negative whatever that is, and then double that. And so 2 isn't going to work either. One thing I'll tell you, because well, we'll just see what happens. 3, and for 3, 1 times 3 is 3, and plus 1 is 4. 12 minus 13 is -1. -3 minus 23 is -26. And of course, I do these at the board, so that's why I quit a little early, maybe. But you have a calculator, go ahead and do it. -26 times 3, that's going to be negative. -14, that's going to be negative. Times 3 again, it's still saying negative. And then -24, still going to be negative. So then I'll try 4. And notice this. Let's see. Here, these are growing. Do you agree? Right there, they're growing, and these are getting less negative, I guess is how I would say it, right? Less negative. So even though it's still staying negative, and that's maybe an advantage of getting that last number, I do feel like I'm still going in this direction. So I bring down my 1, 4, and 1 is 5. 20 minus 13 is 7. 28 minus 23, so I'm now positive still here, and so I get my 5. Then I'm bumping myself back up quite a bit positive, so 20 minus 14 is 6. 24 minus 24 is 0. And so I found my first 0. And do I need to look at any other positive numbers? No, that's the beauty of Descartes' rule of signs, is because I knew there was at most one. I found one, so I don't have to use any more positives. I'm going to use my space a little bit, and now that I know that works, this is my depressed polynomial. Maybe I will just keep going. That I get rid of. This is now my depressed polynomial, and now I'm going to start looking at some negative values as I go. So I'll just do the same thing, -1, -2, -3, -4. -1, I bring down my 1, so -1 plus 1, oh, just kidding, wow, right? I did that wrong, yeah. So -1 plus 5 is -6. Positive 6 and 7 is 13. -13. Did I do something wrong? Oh gosh, wow. Okay, yes. So I've got my 1. -1 plus 5 is 4, right? And then -4 and 7 is 3, and -3 and 5 is 2, positive 2. Wow, I just kind of losing the arithmetic there. -2 and 6, is it going to be 0? No. So that one's not going to work. So if you were writing in pen, it's okay because like it didn't work. So we're just scratching it out anyway. Then we'll try -2. I'll try to do a better job. So I bring down my 1. Then I have -2 plus 5, which is 3. -6 plus 7, which is 1. -2 plus 5, which is 3. -6 plus 6, which is 0. So another victory. So I found a negative answer, and so that tells me I don't have 0 negatives, correct? So I either have 2 or 4, and I'm hoping to get the second one, and then I should have a quadratic, right? And I'll either be able to factor it, or maybe I'll be able to tell if it's going to work. I do have to see more, right? There. And so let's see, I'll circle that, I'll X out that, and do I use this row anymore? Nope. And so now I'm using that row, -3, bring down the 1. -3 plus 3 is 0. 0 plus 1 is 1. -3 plus 3 is 0. Ah, victory. So right now I have x minus 4, x plus 2, x plus 3, and this. What is this? X squared plus 1. So right now I've got x minus 4, x plus 2, x plus 3, and x squared plus 1. And that's, I'll just write x squared plus 1 plus 0x plus 1. So I'm hoping we can in our heads say, oh, if I set that equal to 0, x squared is negative 1. And so that would be the square root of negative 1 is imaginary, right? So does this have real factors? No. And so when our directions are, and by the way, hopefully you have written these directions. This is a product of linear and irreducible quadratic factors. And so that is the answer. Was it called k of x? I barely looked. Okay, k of x equals. And so, oh, that is the answer for this one. Now, I'm going to take a picture of it because I just like it that much. Oh, no, can I copy it if I have all that highlighted? I don't even know either. Actually, I'm going to do something like group it. Where's group? Group. I can't find group. Okay, I'll just copy it then. We'll see if that worked. Okay, so paste. Oh, you don't even know how nervous that makes me when I try to do things like that. Oh my gosh. Okay, look, same rule, right? That's why I put this here, because we've done all that work. But now, now we get to do more, yes, but the last part's going to be easy for us. And in this case, we'll actually just factor it as well. Let's see. This says a product of linear factors. So we are allowed to have I in our factors, okay? And it's not going to be that bad, though. If I need to, I can use the quadratic formula to find the zeros, and then I can do that kind of I thing as well. And but in this one, let's see. I don't want anybody to be unfamiliar with things, but. So we've got all that done, right? So you're kind of glad they used the same one, really. And then we have to kind of say to ourselves, well, can I factor this? So there's a couple schools of thought. You can put it in the quadratic formula, okay? Or because there's no middle term, you can set it equal to 0 and solve it that way. I'll just do that. X squared plus 1 equals 0. I subtract 1. X squared is negative 1. X equals plus or minus the square root of negative 1. X equals plus or minus. I'll actually write it as two things. X equals I and negative I. X equals I and negative I. So then when I write this as factors, I'm going to have x minus 4, x plus 2, x plus 3, and then this last one is x minus I and x plus I. Now that worked out super nice for us. And I'm just going to give you like this little side note. So suppose it had been, what was that other one? X squared and 4 and 5. Well, we have minus 4 plus 5. Yeah, because, minus 4x plus 5. So if you put that in the quadratic formula, you might have gotten, I don't know what you would have gotten, but I'm going to just pretend or something kind of like that. Set it equal to 0 and x equals negative b plus or minus square root of blah, all over, blah, blah, blah. And so then maybe you got x equals 2 plus 5i and 2 minus 5i. When you write that as factors, you have to write it as x minus 2 plus 5i and x minus 2 plus 5i, and then distribute the negative. Just kidding. So minus 5i. And then when you distribute that, it would be x minus 2 plus 5i and x minus 2 Oh, that's what I did wrong. Wow, very good. Thank you so much. and minus 5i, and then plus 5i. The good thing is I actually know when I'm wrong, but you know, it doesn't keep me from making mistakes. So these factors could easily have looked like that. That's what I'm saying for that. And I don't want to leave that on there because I don't want anyone ever to think that's part of this problem as we go. And so the next one is list all of the zeros. Oh, so part C, so we've got this, right? Copy. Part C is the same problem. Ready for it? So that was all the factors, right? Linear factors. Paste. It's one problem. So now part C is what are all the zeros? If you get this far, it's easy, right? Because the zeros are 4, -2, -3. This one is actually positive I, and this one is actually negative I, as we look at that. Now, the next thing, and I'm going to tell you this, if you are given a higher power, maybe like this, and you're just given one complex zero, you can go about that two ways. You can do synthetic division with that. I would never do the short version. You know what the short version is, right? Because you have to multiply complex numbers. So, you know, it gets messy, but it can be done that way. Or you can write it with its conjugate pair and multiply those out and do long division. Does that make sense? To kind of get it down to another quadratic that you can use. So this is our last problem, and I knew that I would be asking you to do a lot of things, and I am still giving you this kind of, I'm calling it an in-class assignment or in-class thing, and it's 4 problems, and I want you to be able to experience those 4 problems before you take the quiz. That's why I have them on here. So here's our next one. So if we have, for number 8, P of x is x to the 4th minus 6x to the 3rd plus 35x squared minus 50x minus 58. Ooh, not 85. So we have that, and we have to write the linear factorization given that x equals 2 plus 5i is a 0. So I feel like we're running a little short on time, and so I think the easiest way to do this is to write those 2 conjugate pair factors, because even though they gave us 1, we know there's 2, right? And then multiply that out, and then divide that quadratic into this, and this is to the 4th, and then see what we get, right? Because it shouldn't. We'll get a quadratic out, right? If we divide a quadratic in, we'll get a quadratic out. So if that's a 0, then I know that x equals 2 minus 5i is also a 0. Is also a 0. So I get these 2 factors. I'm going to multiply them together. I get x minus 2 plus 5i, oops, and x minus 2 minus 5i. And then I'm just going to distribute my negatives, hopefully correctly this time. Am I good to go? Okay, so now I'm going to do that distributive property, and I'm going to get a quadratic here. So let's do that really quickly. And so I'll distribute x first. So Cole, go ahead. Okay. Then, Dylan, I haven't asked you to do any of these. Distribute the -2. And let's see. Matthew, go ahead and do this one. Shh. Okay, so help me as I go because I'd rather not make a mistake. So that's x squared. Let's see, minus 5ix and plus 5ix. Minus 10i plus 10i. And this minus 25i squared is like plus 25, right? So this is x squared. What's my x term? Minus 4x plus 29. So that's a factor, right? And that's why that should give you a clue that it was not real as we go. So now we're going to take that and we're going to divide it into the original problem. Are you ready? So x squared minus 4x plus 29, and I'm dividing it into, I can't see it, but x to the 4th minus 6x to the 3rd plus 35x squared minus 50x minus 58. Can I just tell you what it is? Because you know how to do this, right? So, okay, so this is x squared minus 2x minus 2. Does it factor? Look at it. It does not. But can I find the zeros using the quadratic formula? Yes. So x equals negative b plus or minus the square root of b squared minus 4a. Okay, so 2 plus or minus the square root of, what is this? 8 times 4? 12? Is that right? Do you agree? Oh, sit down. Yeah. Okay, so these are the zeros, right? Shh. So these are zeros, and we had our zeros from up there because I was to write the factorization, linear factorization. So I think it is x, and I'm going to write this because I already had multiplied it out, x minus 2 minus 5i, x minus 2 plus 5i. You know where those came from, right? Yep. And then I have to do the same thing with these. X minus parentheses 1 plus the square root of 3. And x minus parentheses the square 1 minus the square root of 3. Ooh. So here they are. X minus 2 minus 5i. X minus 2 plus 5i. X minus 1 minus the square root of 3. X minus 1 plus the square root of 3. Make sure you get your in-class worksheet. I hand-picked these problems so that you can practice for the test. Oh, yes. Oh, you know what? You have to get it from me because people were in Knowledgeable already have it.